The surface of Mars, section 5.7. Let's get right into it because there's a lot to talk about. Our moon, as you recall, has two very distinct areas, the wider, higher highlands and rougher highlands and the lower, smoother maria. Mars is separated that way as well, but in this case, it's separated by a north and a south hemisphere. The southern hemisphere and the northern hemisphere, very different from each other. The northern hemisphere of Mars is more like the maria of the moon, flatter, smoother, lower elevation. So at some point, essentially it got repaved. So we would say then that the northern hemisphere of Mars is younger. Then, of course, you have the rougher southern highlands of Mars. When I say highlands, I mean this is an area that is considerably at a higher altitude than the north. I mean, that's crazy. 3 miles. Think about it. We make a big deal out of, let's say, Denver, Colorado, the mile-high city, right? 1 mile in elevation above, say, here in South Florida. And yet here you're talking about the entire hemisphere being 3 miles. And that's what you're going to notice about Mars. Okay, everything is kind of wildly exaggerated, which is why it's kind of fun to study it. Okay, now within that area, those southern highlands, there's still another area within the highlands that bulges out even further. A huge area called the Tharsis Bulge. The Tharsis Bulge. Okay, if I could go there and visit a place and hike around, that's probably the area that I would personally go to. That whole area rises 6 miles above the equator. How tall is 6 miles? Well, that's like the height of Mount Everest. So this is just crazy. And this is an area the size of North America. So this huge plateau rising up. That's unbelievable, the Tharsis Bulge. Now, one very, very interesting thing about this is that we think that that particular area did not form as Mars formed billions of years ago. So the highlands themselves go back to the beginning of Mars 4.5 billion years ago, but the Tharsis region seems to have come at some point in the middle of Mars's history. So something created it. It wasn't just there from the beginning, and I'm going to throw out a theory here in a moment, because check this out. On the exact opposite side of the planet, you have what's called the Helis Basin. As we know from previous chapters, a basin is essentially a large crater. Once you get to about 300 kilometers across, we start calling it a basin. Look at that topographical map there, and you can just immediately see that that is an impact feature. And this particular impact feature happens to be, check this out, about 5.5 miles deep. So on one side of Mars, you have a 5.5 mile deep basin. On the exact opposite side, you have a bulge that comes outward 6 miles. Yeah, it certainly looks like there's cause and effect there. And so much like the Helis Basin on Mercury and the opposite terrain on the opposite side that's called the weird terrain, it looks like one caused the other. There was an absolutely mammoth collision that created both these features, the Helis Basin and the Tharsis Bulge on the opposite side. Certainly an impact feature. Look at Mars. Just fascinating. You see in blue there the smoother, lower northern hemisphere. And then all the orange and red, that's all the south, the higher elevation. And then this one particular area of white, that's the Tharsis Bulge. And on the opposite side, you have all of a sudden this deep hole in blue there. Just fascinating topography on Mars. Okay. Well, one of the fun things there about the Tharsis Bulge region is that it has the largest volcanoes in the solar system. One in particular is the most famous, we'll get to in a moment, but unfortunately all of them are extinct volcanoes. They are not active volcanoes, but the big daddy of them all is, of course, Olympus Mons. What a great name, huh? Mount Olympus, the home of the gods. And it certainly earns that title. It is by far the largest volcano or mountain or anything in the whole solar system. How big are we talking about? Well, first of all, if you're going to drive around it, it's going to take a while. The base of the volcano, roughly the size of the state of Texas. It's just mind-blowing, mind-blowing. I think that's actually the most impressive part about it, how wide it is. The height, 15 miles high. If you're wondering for reference, again, about 2.5 times taller than Mount Everest. Now, how is that even possible? Well, simply lower gravity. Okay, in that lower gravity environment, rocks are able to go up higher. Mount Everest is about as tall as a mountain on Earth can possibly be. At some point, rock can't support any more weight. And when you're in a lower gravity environment, I think it's about 38% of our gravity, it allows mountains and volcanoes to rise higher. And so it's not just Olympus Mons, but the ones around it are absolutely epic in scale as well. To give you some reference, of course, Mount Everest is not a volcano. Our largest volcanoes, though, are about the same height as our largest mountains. Mauna Kea, which of course is one of the Hawaiian Islands, its base is 75 miles around, and its height is 5.6 miles. Very comparable to Mount Everest, but most of it, of course, is underwater. So you're just seeing the tip of the volcano there that forms the Hawaiian Islands. Anyway, the caldera, even just at the top of Olympus Mons, 50 miles in diameter. That's insane. That means you could put all of Broward County here where I live. You could put the entire county inside the top of the volcano. Just epic in scale. I've never seen a picture that does it justice. On the left, you see the pictures from the 70s. Really, you can't see just how tall that volcano is. Some better pictures on the right from the 1990s. That's probably just a computer-generated map there, what it looks like from Mars Global Surveyor, I think. But anyway, so it's actually a very shallow, it's not very steep, the rise there. They say you can be on the volcano and not even know it. It's so far in the distance. Remember, it's the size of Texas. You can be standing on part of it and not even realize you're already on the volcano. Fascinating. There it is, looking straight down on it, looking a lot more like a typical volcano that we're used to seeing. But anyway, that's the caldera at the top. Again, about 50 miles across. All right, the other volcanoes in the area, they're only like twice the height of Mount Everest. Yeah, no big deal. Now, it's crazy, just crazy, fascinating. Now, these are all considered to be shield volcanoes for the simple fact that Mars has no plate tectonics, much like Venus doesn't. So all of the volcanoes on Venus and Mars, of course, are shield volcanoes similar to the Hawaiian Islands that have popped up in the middle of the Pacific plate. So those are shield volcanoes on Earth, on average 2.5 times higher, like I said, 38% of our gravity, and that allows them to rise higher. Really interesting stuff. Okay, there are craters on Mars, and one of the really interesting features about the craters on Mars is what we see around them. Okay, we see areas that indicate permafrost, that indicate ice right there in the soil around the crater. Let me show you a picture here. We'll get to the gullies in just a second. First, though, look at this picture right here. You see the outline there is curved. Unlike, let's say, Tycho crater on the moon with the rays of dust kicking out in every direction, here it looks more like you dropped a bowling ball in some wet sand at the beach. And that's what it's like, because when this impact occurred, it melted the ice that was there in the soil, the permafrost. It temporarily melted it, and it did splash outward. So that's a great indication that there's ice right there in the soil. Now, a few years back, we got some pictures like this. Look at those lines. It certainly looks like water, rolled down the side of those craters. But immediately there began an argument about this. Some people say, it could just be rocks, tumbling down the side and making those grooves. This picture I thought was really fascinating back in 2006, where that little stretch there wasn't there before. That little, right here, that little piece of reflective material wasn't there before. And I thought that kind of sealed the deal. Here it is side by side, okay? So something happened there. Well, more recently, as in 2017, now I just saw an article about this saying that, no, it could just actually be sand and dirt and so forth sliding down. So we're still debating, because it would seem odd to have water just kind of gush out of there. I think I was very hopeful for that, but now it's not looking that that's necessarily the case. So who knows? That's what's great about science. As more observations roll in, we'll just adjust accordingly to what we see. So really cool stuff. So that's the first part here. Let's go ahead and talk about another incredible feature of Mars, and that is what they sometimes call the Grand Canyon of Mars, the Valles Marineris, the Mariner Valley. This is absolutely incredible. It's another thing that just goes on like a top 10 list of coolest things in the solar system. We just had Olympus Mons. Valles Marineris is unbelievable. Now, if you see a big canyon on the Earth, again, one thing you might think of first is that, oh, it's where plates are coming together, spreading apart or whatever. No, not in this case, because again, there are no plate tectonics. You might think it formed like our Grand Canyon, where you had the Colorado River carve it out. No, not the case here. So if it's not from water and it's not from plate tectonics, basically it was from an impact. Probably the impact that formed the Tharsis Bulge, it basically cracked open the whole side of the planet and made this incredible feature. The Valles Marineris, just about as long, basically like from, let's say, New York to Las Vegas in length. Just, it's mind-blowing. Absolutely mind-blowing. Versus our Grand Canyon, of course, stretches across. It fits in, northern Arizona. This one, Grand Canyon, our Grand Canyon is about 4 miles deep at the deepest. This one, 12 miles, ours is about a mile deep, and this one is about 4 miles deep. The Valles Marineris, you couldn't even see across it. And just, I can't even imagine being there, seeing this. I mean, I'm blown away. I just recently went to the Grand Canyon here on Earth for the second time, first time since I was a child, and I was stunned, just blown away by how majestic it is. And to imagine that this thing absolutely dwarfs our Grand Canyon, it's just hard to imagine. It really is. So there it is, that big rip all the way across here, almost across the whole face of the planet. That is the Valles Marineris. And we may have some interesting ways, drones or hot air balloons or ways that we could actually explore that someday in depth. All right. So I've already mentioned some of the evidence for water, the splash around certain craters. But there's a lot more than that. We see dried up riverbeds on Mars. But I think the number one thing to remember about all this is that this was all long ago. There's no evidence of this occurring recently. So you have runoff channels, which are old riverbeds, and then you have outflow channels, which are places where there was flooding. Again, long ago, billions of years ago. Okay, so those are our two main types of areas, runoff channels, outflow channels. The outflows were absolutely huge flash floods that occurred, more water per second than the Amazon River. And we'll talk later about what probably caused those. But first, let's look at some of the runoff channels. You see the one at the top? It just looks like a dried up, riverbed out in the desert. And then on the left, yes, that is a delta, clearly a delta, again, from 4 billion years ago. Fascinating. There you see on the right a little evidence of flash floods, where it just poured around and actually went around the craters and formed those little teardrop-shaped islands out of the craters. So that's from flash flooding. What would have caused that? Well, we think at some point those volcanoes were active, and probably when they became active, right around the time probably that the Tharsis Bulge popped out. So you have this huge impact. Volcanoes pop out, they're active, they heat up the planet. All that ice in the soil floods, and of course it's going to roll from south to north and flood the north. So basically the middle history of Mars is very fascinating. Mars was very interesting early on. It kind of froze over, then it had this interesting middle period with this impact and active volcanoes and basically all hell breaking loose. And then it died down again. So the last couple billion years have been very calm compared to that. So now it's kind of just a little dusty world, but there's a lot of activity in the past that's worth studying and very fascinating. And we actually think there was an entire ocean then in the north. Look at that. It's not hard to imagine that being an ancient shoreline, going back, though, to the beginning of Mars 4 billion years ago. Kind of a interesting picture here. Again, first glance seems so Earth-like. It looks like you're looking at a bay, but no, that is just simply dark sand. That's all it is, and the ripples there are caused by the wind. But I've seen many pictures of Mars that are kind of optical illusions like this. Okay. So I think I'm going to have to wrap it up here, and we have one more type of surface feature to talk about, but I'll get to that in the next lecture. Thanks for listening.